Right. Let us discuss two simple problems. Then, after we discuss hazard of electricity and precautions in the use of electricity. Right. Let us take the first problem. An electric oven of 2 kilowatt power rating. 2 kilowatt power rating is operated in a domestic electric circuit 220 volts but has a current rating of 5 ampere. What results do you expect? What result do you expect? Electric oven of 2 kilowatt power rating is operated in a domestic electric circuit that has a current rating of 5 ampere. What results do you expect? If you use electric oven of which consumes 2 kilowatt power and which is connected to a fuse wire 5 amperes, then what happened? First of all, let us find the current drawn by the electric current. How much electric current should be used? It should be consumed. Let us see. So power P is equal to 2 kilowatts. Voltage V is equal to 220 volt. Then current, how much current is it consumes? As we know, power P is equal to power P equal to power P is equal to V into I. Power V is equal to V into I. We have different formulas for power, right? One of the formula V into I. So I is equal to P by V. That is equal to the kilowatts is watts volt. So can you convert it to watts? 2 into 2000 watts. That is equal to 2000 watts. 2000 watts. Substitute 2000 by 220. 2000 by 220. And 0 on the potential approximately we get 9 amperes. Approximately we get to 9 amperes of current. Means it consumes 9 amperes of current. It consumes 9 amperes of current. Approximately it consumes 9 amperes. It consumes 9 amperes of current. So let us do 100. Right? So 11 100 is 99. So 1 9 so 9 point something will come. So approximately 9 amperes of current is actually consumed by the electric oven. But this electric oven is given in the circuit a current rating of 5 amperes fuse wire. 5 amperes of fuse wire. So we know in case of 5 ampere fuse wire is only pass, no damage electrical appliances. But here what happened? 9 amperes of current is flowing. 9 amperes, which is very high. But fuse in the circuit is only 5 amperes capacity. 5 amperes capacity. So when a high current of 9 amperes flows through a 5 ampere fuse, the fuse will get heated too much, melt and break the circuit. cutting of the power supply. Thus, when a 2 kilowatt power electric oven is operated in a circuit having 5 fuse, the fuse will be blow off and cutting the supply. Cutting the supply. So, the fuse wire which is connected is 5 ampere only, but electric oven consumes 9 amperes of current. Excess, more high current is flow, so the fuse wire is gets heated and blow off and cut the connection. This is the one problem. Then this is the one problem. Then let us discuss one more problem after we discuss the remaining topic. The second problem. A circuit has a fuse of 5 ampere. A circuit has a fuse of 5 amperes. A fuse of 5 amperes. What is the maximum number of? What is the maximum? What is the maximum number of 100 watt rating? 100 watt rating bulbs that can be safely used in a circuit. How many bulbs? Means a circuit has a fuse wire 5 ampere. What is the maximum number of 100 watt rating bulb that can be safely used? How many 100 watt bulbs can be used in the circuit if we connected 5 ampere of fuse wire? So let us take the number of first let us know power of a bulb is equal to 100 watt. Let consider number of bulbs is equal to x. Number of bulbs is equal to x. So power of x bulbs is equal to 100 into x watts. 100 into x watts. So use current కాబట్టి voltage V is equal to 220 volts. Then find out the current. So when you know how much of current is passed through through at least one bulb, then number. So I is equal to P by V. So from V is P is equal to VI. P is equal to power is equal to voltage into or potential difference into current. Power how much? 100 by 220. 100 by 220. 100 by 220. So sorry sir. Current already given. How much? I is equal to 5 amperes. I is equal to 5 amperes. So power. How much power? 100 into x. That is equal to formula P is equal to VI. P is equal to VI. So 220 into 5. 220 into 5. So this totally represents P. This totally about to VI. So here 0 get cancelled. 5 1 5 2 2 1 2 11. equal to 11. X is equal to 11. So X number of bulbs used in circuit is equal to 11. Number of bulbs used is equal to 11. So when we use 11 bulbs in a circuit, then no problem. Means we are using a 5 ampere fuse. This is the second problem, the simplest problems. Right. Then let us discuss hazards of electricity. Causes electric shock, and sometimes it is damages internal organs, working of internal organs. If a person happens to touch live electric wire, gets a severe electric shock. In some cases, it causes death also. Short circuiting due to damaging wiring or overloading of the circuit can cause electrical fire in a building due to short circuiting and overloading. Due to short circuiting and overloading, fire accident happened in a building or a shop, whatever. So, what precautions we have to take? We do not touch the electrical appliances with wet hands, and make sure that do not use more electrical appliances at a time, because of due to using more electrical appliances at a time, especially high power rating electrical appliances, high power electrical appliances like refrigerator, electric heater, electric iron at a time causes overloading. The person who happens to touch the live electric wire should be provided insulated support of wood, plastic or rubber. While using electrical appliance, should wear some slippers or wear some gloves, etc. So make sure that all electrical appliances should be given earthing or not. Earthing wire should be given especially for electrical iron, cooler, refrigerator, etc. Should be given earth connections to save ourselves from the risk of electric shocks. Even the earth connections is there, we should avoid touching the metal body of electrical appliance when it is on. So, okay, no problem, earthing wire is given, so no electric shock happened. Instead of that, don't think like that. Even the earthing is given to the electrical appliances, but better should not touch the metal sheets or metal case of particular electrical appliance. Then all the switches should be put in the live wire of the AC current. So the switch is turned off, the appliances get disconnected from the live wire and there is no risk of electric shock. So we should give the connections which concern to the live wire. Once we switch off, then no connection with the live wire, no problem. We should never operate switches of electrical appliances with wet hands. So water is a good conductor. Our body also sometimes conduct electricity. So we should not touch with electrical appliances with wet hands. So when we touch with wet hands, we get electric shock. That's why our elders are instructed us, do not touch the electrical appliances with wet hands. The fuse should always be connected to the live wire of the circuit. The fuse wire should be proper rating material. Should connect the fuse wire to the live wire. Through live wire only current is flow in the circuit, and we should take the proper rating fuse wire instead of using some local made quality that. The household wiring should be done by using good quality of wires. Havels, don't touch the fire. Some different brand electric wires are available in the market. So we should avoid working on live circuit for repairs, etc. So we should cut the supply of electric current by switch off, by cutting the supply from the live. By live wire is keeping on and doing works, it causes some danger. So that's all for today's session. So we completed the chapter magnetic effects of electric current, as well completed the syllabus, of class 10. So thank you.